Welcome to homework.
All right, so problem number 49 basically just states to repeat problem 48 for a particle in the first excited level. So problem number 48 says to consider a particle in a box with rigid walls at x equals 0 and x equals L. Let the particle be in the ground level. Calculate the probability, psi squared, that the particle will be found on the interval of x plus dx. For A, L is equal to 4, B, x is equal to L over 2, and C, x is equal to 3L over 4. So let's start with the normalized wave function for a particle in a box in a ground state. So that's just given by psi 1, and the ground state is equal to the square root of 2 over L times sine of n pi x over L, where n is some positive integer, x is where you're at, your position, and L is the width of your box. So now the probability of finding this particle in the interval x, so we want to find the probability, so probability of finding it between x and x plus dx is just given by, this is more physical, psi of x squared dx. So now for the first excited state, this is for a P. So for the first excited state, for problem 49 here, psi 2 is equal to the square root of 2 over L sine of 2 pi x over L. So now for part A, it wants you to find the probability of finding the box, the probability of finding the particle on the interval x plus dx, where x is equal to L over 4. All right, so P. So I'll write this now. I'll write the psi 2 of L over 4. So x is now L over 4 is equal to the square root of 2 over L sine 2 pi over L times L over 4, which is equal to square root of 2 over L sine times, so that cancels, sine of pi over 2. So that sine of pi over 2 is just 1, so that just becomes the square root of 2 over L. So now the probability becomes the integral from L over 4 to L over 4 plus dx, square root of 2 over L dx squared, which is just equal to 2 over L times L over 4 plus dx, minus L over 4, which is just equal to 2 over L dx. So whatever that interval is. So that's for part A. Now for part B, let's create a new thing here. So for part B, we want for x is equal to L over 2. So psi 2 of L over 2 is equal to square root of 2 over L sine of 2 pi over L times L over 2. So these cancel, which is equal to square root of 2 over L sine of pi. which is just equal to 0. So basically the probability of finding the particle at 2 over L plus some, or x plus dx is going to be equal to 0. So because the wave function collapses at 2 over L. So for part C, we want to do x is equal to 3L over 4. So psi 2 of 3L over 4 is equal to the square root of 2 over L sine of 2 pi over L times 3L over 4. All right, so the L's cancel again. Those, you get 3 pi over 2. So is equal to the square root of 2 over L sine of 3 pi over 2, which is just going to be equal to negative square root of 2 over L. So now, doing the probability integral, P is equal to the integral of 3L over 4 to 3L over 4 plus dx of the magnitude of the minus square root of 2 over L squared dx is just going to be equal to 2 over L times 3L over 4 plus dx minus 3L over 4. So these go away. So that just, again, is equal to the same thing, 2 over L dx. So basically, the probability of finding the particle in this particular box in the x equals, the n equals 2 state is 0 at the center, and then it's symmetric about the edges. So if you have this box like this, it would be something kind of like that, where this is L over 2, this is L over 4, and then this is 3L over 4. All right.